In this video, I'm going to show you guys how to take this basic set of 2018 to 2024 Toyota Camry XSE lights and turn them into something like this. So these lights are usually sealed with butyl, which is very easy to open an oven. You want about a 215 degrees Fahrenheit for around 10 minutes, and they should open up pretty easy. You're going to want to remove your screws first before you do. There are screws along the top in 4 locations, and then you have screws along the bottom in 4 more locations, as well as one final screw in the back corner that you're going to want to remove before you put it in the oven. That would just make it easier to open them up when you do get to that point. Now in this case here, this does not actually have any sealant in it, so I'm just going to open it up real quick right here on the table. Oh boy. So when you're opening them up, you do want to make sure that you are watching your pop tabs. It's 3 across the top here. There's another little plastic one down on the side, a couple underneath. And as you're prying it open, you do want to be careful of those because those can snap relatively easily. If they do, it's not the end of the world in this light, but ideally you want to try to open it up without snapping anything. So once you do get it off, once again, normally you're going to have a butyl glue inside of here, which is a little sticky, so keep that in mind. As you're peeling it, it will kind of spread like cheese a little bit, like stringy, very stringy. So you're going to want to kind of, work that stuff back so that you don't have any fall down inside the light and possibly get on something. You can get it off, but it's usually a little bit more mess than it's worth dealing with. So it's easier just to go around it and try to clean that off as you're opening up the light. In this case, I don't have to worry about it, so I'm just going to open it right up. Now, I do have a couple connections from the back of the light to the front of the light because most of the electronics are actually in the front side here. And so the first thing I'm going to do is go ahead and disconnect this connection here. There's another one that goes to the little corner light, and I will disconnect that one as well. And now we have disconnected the front from the back. I'm going to go ahead and put this one to the side for now, and we're going to come down to this light here. Now, keep in mind the surface that you're working on. I did clean this one off, so I'm good to go. But you could scratch up the lens, so laying down on a towel or something soft to prevent the lens from getting scratched up is a good idea. Next thing I'm going to do is I'm going to remove the front bezel here from the lens itself. In this case, I have 1, 2, 3 screws. 1, 2, 3 screws. So 6 screws total, 3 in the top, 3 on the bottom. So the first part, you can remove this little section here and then come back in here and we'll get this part out. Just like so. Being very cautious on the inside of the light. You can touch the outside of the light and it'll be okay. You can rub off any fingerprints or anything like that. But on the inside, it is a little bit more sensitive. So you're going to want to be real careful with this lens once you get everything out. I'm actually going to put it separately in the other side of the room where no dust or anything else can get to it. And that will keep it new, very clean, very fresh. Now for this build, I am going to be replacing the amber reflector with a clear one. Actually got it right here. And I have already actually sandblasted this one. So it is a clear reflector that is also diffused more for our backlit LEDs. I ideally don't want to see the LEDs shining through. I just want it to diffuse it really well and make it look like it's the entire back of the plate is illuminated. So I will also be doing the same sandblasting on this piece here. So the idea is that all of the clear areas we are going to diffuse with the sandblasting process, which will give it a little bit more of a white look, but it will also hide the LEDs better and make it just look much more seamless throughout the whole build. We're kind of going for like that black-white look a little bit on it.
Yeah.
So the chrome will be stripped from this, so it'll be a black part. I am going to leave the chrome on this, but that's because it will be covered with this white diffuser. The chrome will help the LEDs to shine forward a little bit, so you will not see the chrome on the finished product. We're going to have that all covered up, but the chrome will be in there to help reflect that light outward. For chrome removal, I do use a ZEP degreaser. It's a concentrated industrial strength degreaser. It is a little bit caustic as far as your hands go and stuff, so you're going to want to wear gloves or something like that, or just don't get any on your hands and you'll be okay. But it will do an excellent job at stripping the chrome. Probably less than 5 minutes, all this chrome will be gone just by soaking in that solution. Next up, we're going to go ahead and separate the little turn signal section here from the DRL right there. And for the DRL, we're going to be removing these panels along with all the factory LEDs that's inside. So just like that, the little factory LEDs with their heat sinks have been removed. So now we have access to the back of the lens diffuser here. And we are once again going to sandblast this to turn it into a little bit more of a white. And so it will actually diffuse the LEDs even better. And it will also match our white cover and our white corner reflector. To do that, you're gonna have to remove a couple screws. Just like so. And then we have that part out. And we can pull out the little jewels. This part will be staying black, so I'm just gonna put that to the side. And this is a 2-piece little diffuser, so we'll hit that. The main focus is gonna be the actual outside visible part. I'm not gonna double diffuse. Sometimes I'll diffuse on the back and the front like I did on this piece, and that helps with the light output diffusion a little bit. So if your LEDs are close up to the diffuser, then you kind of want to hit both sides because it will diffuse better. But the more it diffuses, the less output you'll have for light. So you kind of got to play with that a little bit as far as what you do. In the case of this, these are downward facing LEDs. So the LEDs actually shine down, hit the chrome, and then shine out. So it actually makes it a little bit more visible to diffuse this, because the diffusion will actually absorb the LED light and make it a little bit easier to see. Whereas if it was just the reflection hitting down, it shines brighter, but it's harder to see because the sun will also hit that chrome and kind of wash some of it out. Whereas with this, it will absorb more of the LEDs, so it's easier to see. It's not drastically different between the two, whether you do or don't, but I think for the finished product, this is going to look better going all white on it. These are more directional. The LEDs are actually on the back of these little panels here, and they shine forward. And the way that the plastic is created, it actually spreads the light out, so it's not just dots. So it's already a pretty good diffusion tool as is, but we're going to match it with the same color that we have for the other parts. Now on this part itself, for the back side, this is where we're going to be attaching the LEDs. The LEDs that we're going to be using are our UCS 2904 pods. These are 5-volt LEDs with a IC chip on the back side. Now, the biggest difference between these and a lot of the ones that you'll find on Amazon or other places like that is that ours are a high output 5-volt LED. And comparatively speaking, the majority of them are SK-based chips like this, and they put out about 12 milliamps of power per color. These put out 17 milliamps per color. So output wise, you're talking roughly 30% increase, something like that. So it is a significant upgrade in output. Price-wise, they're not horrible for the amount that we're going to need. So that's the way that we're going to go on this build to try to get the most output that you can. Addressable LEDs in general, the color flow series stuff, it is never really high output. We have some stuff that's pretty impressive, like in the RGB stuff. But, you know, comparatively to what you're going to have stock, it's almost always going to be a little bit of a downgrade, depending on what case you're using. So it's something to consider. You know, you want to use the best that you can. And this is pretty close to stock. It is still a little bit of a downgrade, but I think it'll work well for this application. So in order to install these LEDs, we are going to have to trim off a lot of the backside here so that we can centrally locate these LEDs. And the idea being that this panel goes in like that, and the lenses need to, the lens of the LED needs to shine directly in that center point to properly bring that light to the front of this panel. And in order to do that, we got to get rid of all these bumps that were there originally to attach the factory boards. So I'm going to use my ultrasonic cutter and cut those off real quick. You could use a Dremel or something like that if it works better for you. Even a pair of wire snips is enough to cut these back if you needed to, but I've got the ultrasonic cutter, so that's how I'm going to do it. So just like that, I have removed all those little tabs so I can easily place the LEDs where I need to put them. Now, in the case of this one, it is kind of like 3 rows. So the plan is to start in one and then split off into all 3. And that way I don't have to do the programming after. And you keep in mind, if you're using a Blue Ghost controller or something like that, you're going to want to be able to control everything by sections. And sometimes it's beneficial to actually put a splitter in where you know that you're going to have a case like this where I want it to flow uniformly together. So it's beneficial for me to go ahead and do that with wiring by splitting the data rather than just running almost like a grid and then creating 3 sections in the app. This will allow me to create 1 section in the app. These lights are already pretty busy, so I'll have like 7 or 8 sections. And this stops me from having 10 or 11 sections, which the controller is limited to 10 sections. So if that didn't make any sense, you can watch my video showing how to program the Ghost controller, and that'll make a lot more sense. But the more you get familiar with the Ghost controller, the more you'll understand kind of the limitations of the controller and how to work with that. It doesn't have a lot of limitations, but it does have some, and that's definitely something you want to consider before you start laying out your LEDs and wiring everything up, because after you do all that, it's going to be a little bit more difficult to go back and fix things and change things. So I'm going to be splitting data on this one. So for actually attaching the LEDs to this, I do 2 parts. The first thing is this Star Bond. Really any CA glue will work. So a CA glue is like a 2-part glue. It's kind of like a super glue, but then it's an activator. And the way it works is the super glue works like a normal super glue would, but then you have the activator, which makes it dry a lot faster. So think of it kind of like a tack weld. So you use that very sparingly, and mainly because this is very brittle. So it has a strong bond to keep something in place. But the problem is if there's any flex or anything like that, as we traditionally see in a car, it will break free. So if you only use this to secure stuff in place, it will fall off on the car when the person's driving down the road or things like that, and eventually stuff will fall off. So you don't want to just use that. It's a good way to keep something in place. For long term, you're going to want to use this stuff here. It's Gorilla Glue contact adhesive. It's probably my favorite glue of all the stuff that I've used on cars. It dries to a rubbery substance. It has a great bond to whatever you use it on, but it's also removable. I honestly don't think you could make a better glue for what we're doing in retrofitting because of just the characteristics of it, how much heat it can take, and how well it just holds. Really the only thing to keep in mind is that it will yellow after time, so don't use it to cover any LEDs because that will affect output. But as long as you're just using it to secure things in place, the coloring doesn't matter, and it will hold very well forever. I've never seen them disconnect or lose grip on whatever is used to secure in place. So the kind of the way I'm going to go about this is I'm going to run a strip along this section here, and then I'm going to run another one along here, and then the last one will be those three. So 3, 3, and 6 is how I'm going to do it here. So I'm going to get that first one in place right there. Keep in mind the arrows, that does indicate the direction of flow. And obviously with these, you have an input and an output on each LED, and you have to make sure those are straight. So I'm going to hold it right there. I'm going to use just a dab. You hold it there for about 20 seconds and it will have dried by then. And just like that, it is in place, and it will hold it there long enough for us to get the contact adhesive down, and that way it will permanently hold. So there is a little bit of dry time involved here, so I'm going to get this laid out, and then we will set it to the side, let it dry, and work on some other parts while we're going through. If you give it like 2 hours, this stuff will be dry to the touch. You're good to go. You can assemble everything back together. So now I have all 12 LEDs secured in place. Now, these are sold by a strand of 25, so you actually will have one left over, and that's all you need for the lights, so it actually works out pretty well. I did secure them in place with the CA glue, and now they're dry enough that they'll pretty much hold themselves. I don't have to worry about anything there. So what I'm going to do now is I'm going to connect the solder points, like I said, where I split. So the idea being here that you can see I'm starting here, and then this is LED 2. This is also going to be LED 2. So I'm going to connect this to that point, and then we're coming up to the next row here. I'm going to connect these to that point, and that will give us the flow that we need to move outward, where it looks uniform, but I don't have to actually load in 3 different sections. It will still just be one section for this whole light, one input, but it will flow evenly, and this will be my final output that'll go to the next device within the headlights. So I'm going to solder these in place, and then we'll come right back. So now everything is soldered in place. This would be a good point if you do want to check your LEDs before you move on. Just add a little JST or do a connection to a controller. Power them on, make sure everything's running right. Keeping in mind, these are 5 volts. So some of the LEDs we're going to be using are 12 volts. Some of them are 5 volt. And you're going to want to make sure you send the proper voltage to whatever you're messing with. So you could add an input here and then connect them and test them. I'm not going to, because honestly, I don't think I'm going to have any issues. And if I do, I'll pay for it by, having to dig back in and try to fix whatever problems I find. But definitely should consider doing that as you go, just to make sure you don't have any issues. What I'm going to do, my next step, I'm going to go ahead and secure all these LEDs down with this glue. So this is my long-term stuff, and this is just what holds it in place temporarily. So I'm going to go ahead and add a liberal amount to each LED to secure it in place on top there. And then I will set this to the side, and we'll move on to the next panel. So now we're going to move on to this part here. So we're going to have to remove this LED panel, which is just 2 screws. And that panel will come right off. And we're just going to go ahead and toss that. Next up is our top part here. Now these are just little holes that are originally designed for the LEDs. You could use that same LED type that we used here, and it will work. You could use that and just do one for each of these holes. But in this case, I actually prefer to go with our long strips. See, there's the same LEDs, but in a 12 volt version, and they are more dense. So I'll actually be able to get more LEDs in there using the strip than I would if I did the singles. So it'll be a little bit brighter. So I think the outcome is going to be a little bit better. So the way I'm going to do that, I'm actually going to cut a channel out here where I can lay the LED strip right on top, and it'll just shine down. It'll hit this little reflector in the bottom here and shine directly out, so it's easier to see. So I'm just going to use my ultrasonic cutter for that. You could once again use a Dremel on this part and just cut that line. Just keeping in mind the size of the LEDs. It's about 5 millimeters. from side to side. So you probably want to cut like a 6, maybe 7 millimeter section, and that way they just slide right in real easy. So now we have cut the channel there, like I said, and I'm going to kind of figure out how much I need of the strip. So I'm going to cut it right about here. They are cuttable every 3 LEDs, and this is our UCS 2904 rigids. This is 144 LEDs per meter, 12 millimeters wide, and this application is perfect, and it will fit right in there. It is a rigid strip, so there is some flex, but not a ton. But once again, in this case, it'll be perfect. I can cut it right there. So this is the degreaser bucket. It's just a 5-gallon bucket with about $40 worth of degreaser in it. And this stuff will last for a long time. I can just put it right in there. If you're doing this a lot, you're removing a lot of chrome on different things, it's just a really good idea. Just go ahead and have a bucket, and it will last for about a year within the bucket here. And for the most part, it's there whenever you need it, and it works really fast, works really good. So definitely worth having if this is the kind of thing like you retrofit a lot or you're planning on doing stuff like that. Now it does remove chrome from like plastics, but it will not remove it if it's coated with like some really like OEM chrome will have like a coating over top to help protect the chrome from scratches. That will be a little bit harder to remove. And it also will not remove it from metal because the process of chroming metal is different than what it is with plastic. So in the case of plastic, you can see it's already creating a little bit of a fizzling looking thing. It's basically just burning off that chrome, and it will not hurt the plastic at all. It just removes the chrome. I'm going to leave it in there for just a few more minutes, pull it out, flip it around, do this top side, and we will have a black piece. Now you are going to want to wash this off with water to get most of the degreaser off, but that's about it. There's not much to it. I'm not even wearing gloves, but I'm not going to put my hand in it. So for this next part, we are going to be making room for the LEDs behind the reflector on the side here. So we'll pull that right out, and as you can see, I got a little rails behind here. For that, I am going to use the reflector to mark where my little safe points are. So I'm just going to use a little X-Acto knife here and just make some light marks. And that'll give me an idea of where my safe points are so I don't cut too much. So you can see very light scarring that I put there. And once again, you want to be real careful with that. You don't want to cut too hard on there, but just enough that you can see where you need to remove. And I'm going to use the ultrasonic cutter, and I'm going to cut out, leaving probably like 3/8 of an inch away from that line, and it'll be enough room for me to put the strips in behind there. And what that's going to do is give me back spacing. There is some room behind this. You could probably put strips right up there and then drop this in, and it goes right over top, but you're going to see the LEDs, and I want them to be better diffused. So if I cut that out, it's going to give me a little bit more room. So there it is now. I cut it out there so we have room for the channel, a little place to put the LEDs on the back side. I'm going to go ahead and pop this into place, and I am going to secure it on the back side with glue just to make sure that it doesn't try to pop out on me, being that I did kind of carve out a little bit of the part where it actually attaches to the bezel itself. That'll give it a little bit extra rigidity. And then I will also be cutting the strips out, and we're going to be using the same 12 mil UCS 2904 rigid strips that we sell on the website, and just going to kind of fill it out. I'll grab a new strip for this section, but just fill it out along here and up into there. For this whole light, 1 meter is probably about all that you need. Okay, so I have the strips now in and soldered up, and you can kind of see how I split it there. Just the same thing on the data here. So instead of running 2 sections, to just try to keep everything a little bit simple, the plan is to have it flow uniformly in that direction. So I have the input here, and it splits off and comes from here to here, where basically you'll have this first 2 sections, and then it'll match up to this and flow outward. So this is where you can kind of get a little bit creative in how you're doing this stuff. I've actually really come to like the rigid strips and just the way that they kind of hold their place better. You have the easy access pads on the back. If you play it right, it actually makes install a little bit easier and quicker. So I kind of like them for when it comes to an angle or a turn. I have switched to using this stuff versus the 5mm pins. So if you've seen some of my other videos in the past, I used to do the 5mm pins, but what I came to realize is that the 5mm pins are very rigid, which means there is no flexibility to them whatsoever. So I was seeing occasionally an issue where if the lights flex too much, the solder pads on the back of the strips would actually detach. It wasn't like every time or anything, but it was enough that I knew I needed to figure something out, do something a little bit different, and that's where this stuff came in. So this is the same stuff that I use for 5mm LED installs. It is a consolidated electric wire cable. I think it's a 24 gauge solid tin copper, but it's much more flexible, but still rigid. So it's not like using bare wire or something really thin, but it does still have some flex. So it works really well. I can usually just bend it like so and put it in place, solder it right down, snip the end of it off. It works really well, and it's actually really cheap if you consider that's a 100-foot roll. I want to say it's like 20 bucks or something like that. It's not much, and that'll last a very long time. And once again, the big benefit is it does have much more flexibility if the light decides to flex or something. So it seems to eliminate the issue of the solder pads actually disconnecting from the back of the strips. And that honestly was the only issue I've had with these so far, aside from an occasional, like, if you flex the strips too much, it can detach some of the components on there, but you know, that's why you cut and solder the connections to make bends and things. And I've done some pretty extensive bends with these on different lights where you can bend them and angle them and stretch them and stuff. If you're going to do a lot of bending, you're better off just cutting the sections and creating the bend using this connecting wire, and then you won't have any problems. And you'll have a LED that is 12 volt, and it just holds up really well inside of the light. So like long term, you're trying to build a light, you never want to see it back again. If you're a builder, you know, that's ideally. You want to ship it away, have a happy customer for life, and move on to your next build. So that's kind of how a lot of this stuff came about. It's just trying to create stuff that just works. So as you can see, that's how I got it laid down here. And I do have my Gorilla Glue contact adhesive in there to hold it down. I did let it dry for a couple hours. Now I'm back to it to show you guys how that worked. I do have a little pigtail on there right now. That's just the one that came with the strip. But that'll get cut off and rerouted everything. So we're gonna move this to the side. Now we're gonna move back onto this piece. Now we've already attached the top strip here. I do not have my inputs on there yet, but I left those pads exposed, easy to get to, so I can add that input on there, no problem. But what I am gonna do here is our halo. So I find generally 80mm halos fit just about everything. There are always exceptions. I think that a 70mm just feels too small. It usually makes the projector itself feel really small. So it kind of depends on what you're doing. If you're doing like a mini GAT shroud on a projector or something inside a light, then the 70mm probably fits. But if you're doing a set like this, the 80mm fits better. Now, one caveat to that though, is that you do need to trim a little bit to get that 80mm in there. Now, a 70mm probably would just fit right on. If you're looking for something super easy to install, you could go with the 70, but you've also got to consider that if you're keeping this little top section, it sits pretty darn flush with the back part of this. So you're going to kind of have the same problem even with the 70. So in the case here, I do have a 70, and I can show you fitment wise. 70 almost fits in there. You go much smaller than a 70. I mean, even a 70, I think a 70 is just too small. See how close you are to your halo size. Take a little bit more, a little bit more, a little bit more. Just go really slow about it. And that's pretty much any build that you do light-wise. Just take it slow. And, you know, you can always take more. You can never take less. So if you've taken too much, you're going to have to fill the gap or something. So you just take it slow. And once again, the spindle sander works really well for this. You can try to use a Dremel with like a sanding tool. That's a little bit more of an affordable way for a lot of people, but honestly, a spindle sander, I think they're like 150 bucks. If this is something you're going to do a lot of, that tool is one that I use a ton. It just really does come in handy. So if you do a lot of this stuff, I would definitely consider picking one up. If not, you can use the Dremel and you'll probably get away with it. And even to start, you could probably use an ultrasonic cutter just to get the hole started, and then use that sander just to fine tune your placement of the halo. So I finished cutting it out, like I said, with the sander over there on the spindle sander to get it to size. And as you can see, that 80 mil fits in there pretty snug. The little top diffuser just goes right over top, and it fits just right on top of that halo. So I think this is the ideal way to do it on this particular set. But, you know, obviously every set's going to be a little bit different. So you got to get a little bit creative with this stuff and how you're going to fit stuff in there. Always glue everything as much as you can. A lot of people used to use fishing line to attach halos. It's not as much of a mechanical attachment as it is just holding it there. So I don't like it because a lot of times you can see the fishing line for one. Not ideal, but it's just not mechanical. And if you can get the halo in place right where you need it, I will remove our backing tape that we apply, which is mainly meant for easier install. There's a lot of guys that just don't want to go through this extra step to make it look super flush. But if you do, I would remove that tape and use that Gorilla Glue contact adhesive to secure the halo to the bezel. Let it dry, and it won't go anywhere. It's going to stay right where it's supposed to be. I think personally that's the best way to do it. So now I'm going to take these over to the blast cabinet. I'm going to hit them with 220 grit aluminum oxide. Now I use a little bit of a larger air eraser, so it's got a higher flow. So it's somewhere between a traditional air eraser and like a sandblasting gun. Sandblasting gun, you're going to be blowing way too much abrasive. You'll be flying through it. So I mean, maybe you could use that, but I don't like it that style. It's just too much, I think. I'm going to do both sides of this. The process is pretty simple. You're just basically going to hit it with the abrasive media until it has a nice white color on the top. Now, you can hit the front and the back, or you can just hit one side. And that's kind of up to you and how you want to do it. So like, if I were to just hit the back side, it would have like a glossy finish because of the top color coating. If I was just to hit the front side, then it will be less diffused, but still diffused. If I was to hit both sides, it's going to be more diffused. So in this case, I have LEDs that are going to be shining down. So I don't really have to worry about like seeing individual LEDs. So I'm just going to blast the front. But if you were to want to, maybe you got like a WX or something like that, and you want that front C light to hide the LEDs really well, you're going to want to hit both sides. And it's kind of like a double layer of diffusion within it. So just keep that in mind depending on what you're doing. It's going to be the same thing on these, same story. I'm just going to hit that front side so that the back side can still direct that light outward without too much interference. So as you see, I got them blasted now, and it has a nice diffused look to it. You're going to want to blow that off with some compressed air or something like that to get all that excess abrasive media off of the pieces. But as you can see, it turned out pretty darn good. So it's going to help diffuse that LED, make it look a little bit more clean, as well as kind of get rid of all that clear and chrome from the front of the light. So I think it'll look a little bit better. So like this, the Camrys, being that they are recessed for the actual projector, it makes it a little bit more difficult to get in there and put something on. I've had a lot of people ask, can you put custom sized halos like hexes and things like that? And the answer is, Yes, but it will look like garbage. I've seen other people put like hexes or other shapes, and it's just the problem with the shape of that opening. There's not much room. There's not a lot of options without going round. And within round, you've got the 3/4 halos and the round halos, and that's it. There's nothing else that is going to fit that size. So unfortunately, if you want it to look clean, you want it to look good, this is about the only kind of halo that you can fit inside of this particular Camry set. So there's that part. Now, for the top here, I am going to cut this little tab off because it does interfere with the LED strip down here. So we'll cut that off, but other than that, this is pretty much done. There will be some wiring involved here shortly to get everything wired up and ready to go on that side. So we're going to move back onto assembly of the bezel, putting everything back together and then wiring up and then getting that into the lens so we can move to the back side of the light. So for that, I do at a certain point want to put gloves on. It helps to reduce the chance of fingerprints or things like that, which I mean, obviously I've already still got some on here. Most of that's just going to wipe right off. If you are working with chrome and you're trying to keep it chrome, you probably want to wear fingerprints from the beginning, because chrome is really easy to actually rub off with like a microfiber, and so you want to be really careful. But I'm going to go over this and get all the fingerprints off, clean everything up real good, and then we'll start putting all the pieces back in. So you can see I have all the wiring finished on this light now, and it's a little bit busy, but basically this is a 5-pin JST. So I've got 5 volt and 12 volt. I'm going to put the inverter on the back side of the housing. Sometimes I'll put it on the front, it just depends. I do have some 5 volt for the demon eyes, so I wanted to have 5 volt for the demon eyes, and then I'll run 5 volt through here to the 5 volt LEDs, which are our pods as well as the halo. And then we got 12 volt going across the turn signal section here, as well as the corner lights on this section. So I did need 12 and 5, and the way I've got the data coming in, data comes in, goes to the turn signal. From the turn signal, it goes up to the 5 mil, runs up along the 5 mil, comes out here, and it goes into the halo, and then from the halo goes out to the side. So that way it does flow uniformly, but I still will have to do some programming within the app to make sure that it flows together. So instead of here, then there, then there, it'll just kind of flow very uniformly overall. But it's going to still limit my sections. I won't have quite as many as I would if I had done things a little bit differently. So it'll work pretty good overall. Like I said, do have the JST there. And for the most part, yeah, everything is done on this side. I got it put back in. Gorilla Glue all over the place. So for inside of this light, there's a couple things that I'll be doing. I do want to add some breather patches, 2 along the top and 2 along the bottom, and you want to space them out evenly. The big thing with the breather patches is it helps to reduce the chance of condensation in the lights, which is something you'll see in a lot of builds where people do not add some extra breather patches, breather vents, something to help the light control temperatures a little bit better. One of the biggest reasons condensation happens is because the inside of the light is not the same temperature as the outside of the light. So the better the light can breathe, the less likely you are to have condensation. Now that's up to a certain point, because you also want to consider that if it's icy out or really, really cold wherever you're at, if the light breathes too well, then it will not be able to keep ice off the front of the light. So, you know, there's like a happy medium there. I find that in general, if I do 4 vents on each light, 2 at the top spaced out and 2 at the bottom spaced out, it works well. The breather patches that we sell are waterproof, so water will not get in them, but it does allow them to breathe. The reason why you want to space them out is because you can still get hot spots. So if you were to put 2 patches right here, even though theoretically you're venting the same amount of air, you could develop a hot spot in the far corner. So you want to be careful of that. So ideally you want to space them out. I'm going to put 1 here, 1 there, and then 2 about the same area on the bottom. And that should alleviate any issues, at least with the Camrys, of having that problem. But you know, it's going to depend on your lights. Some lights you might want to have more than that. We're also going to be etching the lens and installing demon eyes on this, as well as running our plug out the back to connect to the controller. And on this light, we will have to tap into the turn signal. On the driver's side for the Camrys, we tap into the turn signal and the DRL, and that way we can send that to the Ghost controller, make everything super easy, plug and play. And just like that, with a very small flathead screwdriver, being very cautious, I was able to get it to fall right off. I did lose a very small amount of plastic right there. Doesn't affect the lens at all, but just keep that in mind. If you do this too much, you could snap the whole lens. So be really careful. Do it very gently, just pry it, and you'll hear it start to pop, and it'll come right off. It's not too bad. Most headlights use glass lenses and they fall right out. They're really easy to remove, but that's just the way the Camrys are. One nice thing about it though, they do have this metal ring that goes right over top, so you don't even have to glue it back down. This ring will hold it in place, but to get it off, you do have to pop that right off. Now, we are going to etch that lens, so we do have a plan for that. And for the demon eyes, we are going to be using addressable demon eyes. These are the 5-volt versions. Depending on when you're watching this video, we may have the 12-volt out. But right now, the 5-volt is what we have. And a 5-volt is a pretty nice layout because it is, once again, addressable, RGBW. And it also has a tap. So we can run this to the low beam power on the projector, and that will allow us to turn the demon eye off when the headlight itself is on. So in the case of the Camrys, when you're running down the road, your DRL is the main headlight bulb, so it actually does turn them on. So what happens with these a lot of times with really any demon eyes or LEDs or anything like that, if they get excess heat from the projector, sometimes it'll burn them out. And really just the simple solution is to turn them off while your projector is on. You can't see it anyways because the projector is going to overpower the demon eye. So this is just a nice way to be able to do that, and we have incorporated that into our demon eyes. It also has an input and an output, so it makes it a little bit easier if you're trying to do a plug and play setup with like all 5-volt stuff. Maybe you want to do the same build, but you just want a demon eye and a halo. This would make it pretty easy to do that. But in this case, I'm going to be doing a little bit of something custom. I am going to run 5-volt to the demon eye, and I'm going to run the data in and the data out to come from the demon eye out to the front of the light. But I am not going to worry about the 5-volt out. So we'll run that a little bit differently, a little bit more custom in that way. As far as the demon eye placement, for the most part, it'll slide right in like that. On this particular model, I am going to cut the sides off because it's not the right size for this. Whether 3-inch or 2.5, it doesn't matter. It's not the right size for this particular housing. So all I gotta do is just cut this off just like that, so that way it will clear, and then I will glue this into place just right like that. And that way, when I ended up putting this back on, it won't get in the way of the actual demon eye bracket. So that's the reason why it's cut off like that. I will also have to remember to tap this in. As far as the projector goes, most of the time you can indicate where it is just by looking at the projector and the layout. So we got the fan here, so you're not looking for the fan wire, and that comes out along here. Then you've got the flapper wire here. Now that's for your high beam. So when the high beam activates, this opens and closes. But what we're looking for is the low beam LED power, which in this case is right here. You can see it runs into a circuit board, and that circuit board has some LEDs that are down inside of the projector. So I am going to have to tap into this one. And if you're not sure which color is which, you can send, I would start at like 9 or 10 volts just to be safe. Some LED projectors are a little bit lower voltage than 12. But you can tap into these wires to determine which one's power, which one's ground. and that way you're less likely to accidentally tap the ground. If you tap the ground, it's not going to hurt the demon eye, but it won't turn off. It'll just keep running when the projector turns on, so you might have a shorter lifespan on the demon eye itself. So you do want to try to find out which one is your high and which one is your power, which one is the ground for that low beam projector. And once again, the easiest way to do that would be to hook it up to a voltage meter at a lower amperage or at a lower voltage. That way you don't overpower it. I know these are actually 12 volt projectors, so I can send 12 volt and be okay, but many of them are 9 volt. So you want to be careful. If you send 12 volt to it, you could fry the LEDs. More than likely, they're just going to get really hot. So, I mean, as long as you're only doing it for a couple seconds, you should be okay. But if you have a power supply with adjustable voltage, just go ahead and turn that down to like 9 volts or so. And you may have to turn it up. If it is a 12 volt, 9 volt may not be enough to light it up. So I got everything wired up. I've got my quick connect plug here for the front side of the light. I've got the wire ran out the back through our cable gland. So we have easy access to the plug here. Once again, I do like to use the waterproof barrel plugs. Makes everything a little bit easier for install. I've already got the harness made. I do have videos going over that to show you how I do make the harnesses on these lights. It's pretty typical across all the lights that I build. So check out that video if you want to see how I do that. And I have etched the lens for the projector. Once again, I do have a video going over how I do that as well. I do use a laser cutter and an air eraser to do my shapes and designs, so it gets a little bit more depth, as well as a much more detailed design on the etch itself. So definitely want to check that video out as well if you want to see how I go about that process. Beyond that, it was just basic wiring. I have 12 volts coming in through the plug. I have an inverter. I've actually got it tucked below the projector. And then I've got it split off, so the demon eye is 5 volts. The power and the data comes into the demon eye. The data comes out of the demon eye and goes into this plug here, as well as 12 volt and 5 volt goes into this plug as well. So there's not a whole lot on the back side here other than that. I did tap into the turn signal here, which is the, in the case of this particular light, it's a little white wire that's here. And then the DRL wire, if you're doing the driver's side, is the black wire here is your DRL. So it gives you a little idea just in case, depending on what build you're doing. This one is not for an XSE. This is actually for a TRD. So we do have an adapter plug here that will allow this XSE light to plug into the TRD. You can get these from different places. I believe High Rev sells them. ACL, Automotive Custom Lighting, sells them as well. I do have the cutoff wire, which is right here, and that is wired into the power on the projector. Once again, this one is a 12 volt, and I did show you where that power is located on that. The actual color of the projector is kind of like a grayish one. The white is the ground. So just keep that in mind if you are using this exact set of lights. It may vary depending what brand you are using. This is not a Toyota brand. This is another manufacturer that made the XSE style light. So it may vary a little bit depending on which one you're using. I have drilled the holes for my breather patches. I've added the breather patches as well. So everything on this one is ready to go. So I am now going to seal up the lights. Once again, I do have videos covering that, so I'm not going to bother on that one. But in the case of this one here, because there is no butyl in the channels already, I will add fresh butyl to the channels, put the lenses on top, put it in the oven about 215 for about 10 minutes, press it into place, put the screws in to hold everything in place, and I will add a screw right about here and right about here. And you'll see in a lot of lights, especially if you open them up, there's probably staples there when you open it up, so you're going to want to remove those staples, and you want to probably put some screws in there in its place. It's because for the design of the light, this is an area that it likes to try to separate at. So put the screws in right there, you're pretty good. Other than that, there's screws all over this light. So normally I put a lot of screws in lights. There's no need to, because this thing has screws all over the place. Just these 2 points right here are a little bit of it seems to want to separate there. So it helps to hold it together, put some screws, and it keeps it together so you don't get any leaking. So I'm going to go ahead and seal this one up. I've already got the controller made, like I said, so the next part, we'll have it on the bench, do a little bit of programming and show you what the end result is. So I got the lights sealed up, and once again, I did get my little support screws in there, the breather patches in, everything's done. Lights are good. Now I got them on the table here. Everything is hooked up for electrical, and I have them wired up to the turn signals. Now, I've already programmed them. Once again, I do have a video going into great detail on how to program, how best to program your lights, but here is our startup. We have the turn signals. Shutdowns. When you start, shut down the car. And once again, there are many different modes that you can do with the Blue Ghost to change that around. And then the quick button show modes. So you can see it really does change the looks of the XSE lights a good bit for what it is. Obviously, there's only so much that you can do with these lights because they're already very busy. So trying to drastically change the look of them is a little bit of a challenge. But, you know, in this case, it's a very nice two-tone look. You have that white and the black, and it does flow really well, I think. You know, if I owned a Camry, I'm not sure what set I would put on my Camry, to tell you the truth. I love the jewel eye Lexus style look, but these are pretty eye-catchy too. So it's kind of a hard debate between which direction to go. Solid option either way, I think. Probably would not stick with the SE LE lights. I think they're a little bland, but between these two, this and the Lexus style setup, I'm not sure. They both look pretty darn good, but that's how I made them. Now you guys know everything that was used in these lights was purchased at nextlevelneo.com. If you want to build your own set, reach out, let me know. I have everything on the site. If you need help finding parts for the build, let me know and I can help you figure out what to get. Thanks for watching the video, and if you enjoyed content like this, please like and subscribe so that you don't miss any future videos where we do a lot of stuff like this on a regular basis. So thanks for watching, and check out nextlevelneo.com for all your lighting needs.